Hello everyone, I Mayuriba Zala. Welcome to presentation of our final year project. Our project title is Smart Flower Solar System. Our team ID is 86921. Before I present our project, I would like to thank behalf of our whole team, our guide, Professor Vidita Kanani. Now I would like to introduce our team. Our team leader is Janvi Patel and other team members are Nakum, Dimpal, Virda, Soham and I am Mayuriba Zala. Now I would like to start introduction of our project with the observation made by us. So basically we observed that due to the less energy resources we are now creating a new need for new energy, and that energy we can get from the sun. The current system does not produce as much energy which we need. We need a new technology for the new energy. By using this new technology, we can get a more energy from it. Current system is rooftop solar system. In this, the solar panel is fixed in a one direction. Once it is installed, it will not movable. Due to this, we not get a more energy from it because it is fixed at a one axis. Its maintenance is also high and it's require more space. Due to this problem, we implement a smart flower solar system. The smart flower solar system is our problem solution. It is a dual axis system. It will rotate with the direction of the sun. When the sun is rise and the system is open itself and rotate with the sun. And when the sun set, it is also close itself. This system required less space and low maintenance and produce a 40% more energy compared to the traditional rooftop system. This system is look like a sunflower. That's why it's called a smart flower solar system.
Hello, myself Soham Virda. I will give information about component of smart flower solar system. First component, solar panel. Solar panel is designed for absorb the sun rays like a sun. Sun is source of energy for generating electricity. Photovoltaic module is conversion of light into electricity using a semiconducting material that exhibit the photovoltaic effect. Generally, modules use wafer-based crystalline silicon cell or a thin film cell. This cell must be protected from a mechanical damage and moisture. Modules electrical connection are made in a series to achieve a desired output voltage and it parallel to provide desired current capability. The application of solar panel: first, solar heating, solar pumping and solar drying. The specification of solar panel: first, supply voltage 6 volt, second, cell type crystalline silicon, third, cell number 12 cell, fourth, weight 12 gram, fifth, operating temperature -20 degree Celsius to +16 degree Celsius, 6, dimension 60 mm, 50 mm and 3 mm, 7, back cover PCB. Second component, Arduino Uno. Arduino Uno is a microcontroller board based on 8MEGA328P. It has a 14 digital input and output pin, 6 analog input, 16 MHz quartz crystal, USB connection and power jack. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or a power it with a AC to DC adapter or a battery to get started. The application of Arduino Uno. Arduino Uno is used for a design of a basic circuit design, developing project based on a code-based control and automation system. Now, specification of Arduino Uno. Operating voltage 5 volt, input voltage 7 volt to 12 volt, digital output pin 14, analog output pin 6, DC current per IO pin is 40 mA, SRMA 2 kb, square prom 1 kb, clock speed 16 mH, length 68.6 mm, weight 25 gram, flash memory 32 KB of which 0.5 KB, maximum supply voltage 20 volt. Third component, stepper motor. Stepper motor is a brushless DC motor that rotates in a step. As we active the winding step by step in a particular order and let a current flow throughout them, they will magnetize the stator and make electromagnetic pole respectively that will cause the propulsion to the motor. Application of stepper motor. Stepper motor is used for a hard disk drive, robotics, antennas, telescope and some toys. Stepper motor cannot run at a high speed but have a high holding torque. Now the specification of stepper motor. First, voltage 5 volt, current 400 mA, drive system bipolar, frequency 100 Hz, DC resistance 54 ohm. The fourth component, charge controller. A charge controller, charge regulator or a battery regulator limits the rate at which electrical current is added or drawn from an electric battery. Is give a protection against over voltage and overcharging, which can reduce a battery performance or a lifespan and may pose a safety risk. The application of charge controller. Charge controller is used for a solar battery charger. Its function is to regulate the voltage and current from the solar array to battery. Now the specification of charge controller. Model DX10A, volt voltage 12 volt, charge current 10 ampere, discharge current 10 ampere, maximum solar input less than 41 volt, USB output 5 volt to a maximum, weight 150 gram. Fifth component, LDR. LDR means light dependent resistor. This resistor works on the principle of photoconductivity. It is nothing but when the light flow on the surface, then the material conductivity reduces and also electrons in a valence band of the device are excited to conduction band. This photon is the incandescent light must have energy greater than the band gap of the semiconductor material. This makes the electron to jump from a valence band to a conduction band. This device depends on the light. When light flow on the LDR, then the resistor decrease and increase the dark. When LDR kept is in a dark place, its resistance is high, and when the LDR is kept in the light, resistance will decrease. The application of LDR is these devices are used where there is a need to sense the presence and absence of the light is necessary. These resistors are used as a light sensor, and the application of LDR mainly include a alarm clock, street light and light sensing meter. The specification of LDR: type coating, light resistor 10K to 20K, dark resistor 2M, impress voltage DC 150 volt, operating temperature -20 to 60 plus 60 degrees Celsius, power dissipation of 25 degrees Celsius to 30 M volt. Now 6 component, battery. A battery is a device consisting of one or more electrochemical cells with an external connection for a powering electrical device such as a flashlight, mobile, electric cars, phones, etc. When battery is supplying electric power, its positive terminal is the cathode and the negative terminal is the anode. The terminal marked negative is the source of electrons that will flow through an external electric circuit to the positive terminal. Battery is used for store DC power. So this is the information about component of smart flower solar system.
Myself Dimpal Nakum. Now I will explain the block diagram of the smart flower solar system. Figure shows the block diagram of microcontroller based system. The design combines the microcontroller with the stepper motor, tracking controller, LDR sensor and communication interfaces. So first of all we give power supply to the Arduino. Then the system receives sunlight onto the light-dependent resistor, where the LDR acts as the solar detection tracking sensor. When the sun is at the right to the solar panel, the right LDR has a small value resistance and the left LDR has a no light, and the software in the microcontroller translates these two signals to control the stepper motor to rotate the panel to the right. Now, solar panels produces the DC power that is connected to the charge controller, which is fundamentally a voltage or a current control to charge the battery and keep electric cells from overcharging. Battery is used for store the energy produced by the solar panels.
Myself Janvi. I am going to discuss flowchart of project. First of all, LDR were used as light sensors, two for the east-west and two for the north-south orientations. If light intensity on both LDR is same, it means their resistance would be equal and hence the same voltage to the controller. Solar tracker will maintain its present position. If intensity on LDR east is larger than intensity on LDR west, the resistance of LDR east will be lower than the resistance of LDR west, resulting voltage east greater than voltage west. Solar tracker will move toward the east. If intensity of LDR west is larger than intensity on LDR east, the resistance of LDR west will be lower than the resistance of LDR east, resulting in the voltage west greater than voltage east. Solar tracker will move toward the west based on the above state condition. The light intensity of east and west LDR compare and according decision is made whether to move the panel is east or west direction. After proper orientation in the east-west direction, south-north orientation is checked and implemented. Each time is the positions of the sun in change, the controller repeat the same flowchart. Algorithm and orientation is the panel in the sun's direction. Then let me explain project code. And now must be thinking how we are going to implement. Idea is practical code and practical circuitry. So we use the Arduino microcontroller that the download to Arduino software. That LDR is sense that servo is rotate to the 0 to 180 degree. Rotate that solar panel is open its flower shape. Then stepper motor is rotate to 200 per resolution and 20 rpm of speed rotate then sun direction. So now we discuss about our features. First of all, smart cooling. Second one, smart use. Third one, self-containing. Fourth one, self-cleaning. Fifth one, more energy. Then we discuss about of applications of our project. First one, houses. Second one, industry. Third one, farm. Fourth one, garden. Five one, schools. Six one, colleges. Now, due to some reasons, prototype is not working and the not final project. Let how to make prototype.